In this video, we are going to solve example on Laplace transform and plot its RoC. So let us have a signal x of t given as e raised to minus at u of t. So we are supposed to find out its Laplace transform. So first of all, we need to write equation of Laplace transform. So we know that Laplace transform is given as x of s equal to integration minus infinity to plus infinity x of t e raised to minus st dt. Now substitute the value of x of t in this equation. So we get x of s equal to integration minus infinity to plus infinity x of t is e raised to minus at into u of t and the basis function e raised to minus st dt. So here we have u of t in our integration. So let us substitute the value of u of t. So we have u of t equal to 1 and 0. So it is 1 for t greater than or equal to 0 and for 0 for t less than 0. So we can split up the integration. So x of s becomes now this integration can be splitted from minus infinity to 0 where u of t is 0. So the entire integration becomes 0 into dt plus integration 0 to infinity u of t is 1. So the remaining values are e raised to at into e raised to minus st dt. So here let us simplify it further now. So we have to only evaluate the second part of integration. First part becomes 0. So integration minus infinity to it is 0 to infinity. Integration 0 to infinity. There are two exponential terms, so we can add the powers of this exponential. Now keep in mind here the very crucial thing. Whenever we are combining the exponential terms in case of Laplace transform, always take care of the limits. Here in integration we have limit 0 to plus infinity. So whenever we have the limit plus infinity in the integration, always take negative sign common in the exponential term. So e raised to minus, so the first term is at, so the coefficient of t is a plus s, because already we have taken minus sign common, into t dt. So always simplify this exponential term in this way. Depending on the limits of integration, if it is plus infinity, take negative sign common. If in the integration limits are minus infinity to 0, so here we have minus infinity, so take plus sign common in the exponential, vice versa sign in the exponential. If limit is 0 to infinity, that is we are only concerned with the infinity term. If in the integration we have positive infinity, take exponential power as negative, and if in the integration we have minus infinity, in that case take exponential power as positive, vice versa kind of thing. Now let us simplify it further. So if we take integration of this equation, we get integration of e raised to minus a plus st, so it is minus a plus s into t divided by minus of a plus s with the limits 0 to infinity. So let us simplify it further. Upper limit minus lower limit. So upper limit is infinity, so e raised to minus a plus s into infinity minus lower limit is e raised to minus a plus s into 0. and both the terms denominator is minus of a plus s. Okay. Now we know that e raised to minus infinity is 0 and e raised to 0 is 1. Here we have to compute RoC at this point itself. We can compute RoC once we get the final answer, but it is always convenient to find out RoC of Laplace at this step itself. Now see how to find out RoC. Now let us consider the first term, which is e raised to minus a plus s into infinity. So this term is e raised to minus infinity, which is equal to 0. So if this term becomes e raised to plus infinity, in that case we have e raised to infinity equal to infinity. So our answer will become infinity if we have e raised to plus infinity in our equation. But here e raised to minus a plus s into infinity, so it is e raised to minus infinity. But this term becomes e raised to minus infinity until and unless the value a plus s is greater than 0. The moment a plus s becomes less than 0, this exponential power will be minus of minus infinity. Then it will becomes e raised to infinity and our answer will be infinite, which is not the desirable solution. So here, to find out RoC, we need to take this condition into consideration. So here, to get e raised to minus infinity as 0, we must have a plus s greater than 0. Then and then we can get the finite answer. Similarly, for the second term, here it is e raised to minus a plus s into 0. So here we are multiplying the exponential power with 0. So no need to consider the equations, because whatever is the condition for a plus s, if you multiply it with 0, the entire power becomes 0 and e raised to 0 is 1. So here we did not to consider this particular bracket a plus s. So here we get the condition of RoC as a plus s greater than 0. So we'll simplify it at later stage. So let us first find out the answer of x of s. So this is our equation for x of s. So now this x of s is equal to, so e raised to minus infinity is 0. So first term becomes 0. For first term to become 0, we have a condition that a plus s is greater than 0, and that condition is called as condition of RoC. So first term is 0 minus second term is e raised to minus 0. So e raised to 0 is 1. So 1 upon minus of a plus s. So our x of s is equal to minus minus becomes plus. So it is 1 upon a plus s, which is the required answer for given example. But remember, this doesn't complete the entire numerical. Here it is mandatory to plot RoC. So to plot RoC, we have to draw S-plane. So S-plane is nothing but sigma versus j omega, and for this RoC we have got a condition that a plus s should be greater than 0. So let us simplify it. So s is greater than, so let us take a towards right hand side. S is greater than minus a. So RoC can be defined as s greater than minus a, or real part of s is greater than minus a, or simply sigma greater than minus a. So this is the required RoC. Now we are supposed to plot this RoC on this particular sigma versus j omega graph. To plot this RoC, so condition is sigma greater than minus a. So let us plot minus a on this graph. So minus a will be somewhere here, and the condition is all the values of sigma greater than minus a. So we will be drawing a perpendicular line at minus a, and the region is greater than minus a. So the region will be this part. This is the RoC for the given example. So it is mandatory in case of Laplace transform to find out RoC in each and every example. Though it is mentioned in the question, it may not be mentioned in the question, but compulsory you have to draw RoC whenever you are finding Laplace of any signal. So this is a simple numerical. We have taken x of t as e raised to minus at u of t. We have substituted this x of t in the base equation of Laplace transform. We have computed that integration by substituting value of u of t. Now whenever we substitute upper limit minus lower limit, at this point itself find out the condition for RoC. Generally we can find out this condition once we get the final answer. From this equation also we can find out the RoC. To get this answer as finite, a plus s should be greater than 0. Okay. So in that way we can find out, but the most prominent and appropriate way to get correct RoC is while putting the upper and lower limit. So at this point itself, it is always convenient and good practice to find out RoC.